Hello, and welcome to today's Safety and Health webcast, Combustible Dust Safety, Cleanup and Engineering Controls, sponsored by Camphil Air Pollution Control. I'm Kyle Morrison, the Senior Associate Editor with Safety and Health magazine, and I'll be moderating today's session. Thank you for joining us. We'll start the presentation in a few minutes, but first I'd like to go over some housekeeping items. The views of the speakers and their organization are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Mention of any commercial enterprise, product, or publication does not mean the Council or the magazine endorse them. At the end of today's webcast, we'll have a question and answer session. To ask a question, simply type it in the text box located in the lower left-hand corner of your screen, then click the Submit Question button. You can feel free to ask a question at any point during the presentation. You don't have to wait until the question and answer session begins. We'll try to answer as many questions as we can, but due to the high number of participants today, we may not get to all of the questions. However, any questions that are asked but not answered will be forwarded on to today's speakers. At the end of the webcast, you'll be asked to complete an evaluation survey, and I'll talk a little bit more about that after the presentation. For basic troubleshooting information, please click the Help button located on your screen. This webcast will be archived for 3 months, so you can access it after today's live presentation. Within about a day, just simply return to the same URL to access the webcast. Okay, with that, I think we're ready to begin. Our speakers today include Case Ferguson and Jennifer Tedder. Case has been with Camphil APC since 2005, and he has experience in dust collection equipment marketing, production, and technical support. Jennifer is the Aftermarket Regional Manager at Camphil APC, where she works with customers to meet their dust collection and explosion protection goals. Case?
Great, thank you. Wow. Well, hello, everybody. I feel honored to be able to be a presenter to you today, and I'm blown away by the number of attendees today, so thank you all for joining me. So I moved back from Kuala Lumpur, Malaysia, a year ago, and getting back into the U.S. market. And I have to say it's been interesting to drive around and meeting with manufacturers and processors around the area that I travel and hear what processors and plant managers and engineering managers have to say about NFPA. It reminds me of a Chinese idiom that I know. It's xia zi mo xiang. That it's called the Chengyu, is a 4-character proverb that talks about 5 blind men that feel an elephant, but only one part of the elephant, and they're asked to describe what an elephant is based upon what they touched. And one person touched the tail, and he described an elephant as kind of like a warthog type animal. Another blind man touched the leg of the elephant, and he described an elephant as a stout, sturdy tree. Another blind man touched the trunk of the elephant. He described an elephant as a snake. And the final blind man touched the ear of the elephant, and he described an elephant as some type of large canvas or balloon. And I feel that the understanding out there of NFPA, of the combustible dust standards, can be like that proverb where people get a flavor, understand maybe a section, a portion, but don't understand holistically the standards that are out there that are meant to help an owner-operator help their facility be safe and help their employees be safe. So my goal, Jennifer's goal, and everyone here is to give you some good information, some very specific information, so that you can get a very well-rounded picture of NFPA, so that you can go back to your facility and ask the right questions. Today we're going to be covering, I would say there'll be 3 sections of our conversation. The first section will be going over the various NFPA standards, some of the NFPA standards. 654, we'll focus on 654 and 484. Then after a discussion on the codes, we'll move into a section I titled Engineering Controls, where we'll look at industrial dust collection design, guidelines that are appropriate for and comply with NFPA standards. And then my colleague Jennifer Tedder will then discuss the role of OSHA and shortfalls to compliance. So, NFPA 654, the guiding dust document. If the customer believes he has a combustible dust application, the owner-operator can use NFPA 654 to define the risk as well as set forth the process hazard analysis to define his or her risk and develop a plan of action based upon a process hazard analysis. Some of the highlights from NFPA 654 that I thought relevant to a bird's eye view of this guideline include Section 1.1.1, which states this standard shall apply to all phases of the manufacturing, processing, blending, pneumatic conveying, repackaging, and handling of combustible particulate solids, regardless of concentration or particle size, where a material presents a fire or explosive hazard. So all facets of the manufacturing process. Section 1.5.1 states the retroactivity. Unless otherwise specified, the provisions of the standard shall not apply to facilities, equipment, structures, or installations that existed or were approved for construction or installation prior to the effective date of this standard. Where specified, the provisions of the standard shall be retroactive. So at a cursory glance at the standard, you might think that it's not retroactive, but in fact, Section 1.5.1 lays the groundwork for the retroactivity, which is stated in 1.5.2. In those cases where the authority having jurisdiction determines that the existing situation presents an unacceptable degree of risk, the authority having jurisdiction, or I'll reference it as AHJ, shall be permitted to apply retroactively any portion of the standard deemed appropriate. So the standard is retroactive based upon a determination of the risk by the AHJ. Also, Section 1.5.5 states when major replacement or renovation of existing facilities is planned, provisions of the standard shall apply. So let's say the facility was built prior to the standard. Any changes to the facility, major changes to the manufacturing process, then the standard will apply. It's also worthy to note that at Section 1.6, nothing in the standard is intended to prevent the use of systems, methods, or devices of equivalent or superior quality, strength, fire resistance, effectiveness, durability, and safety over those prescribed by this standard. And this is laid out in Chapter 5, Performance-Based Design Options. Under Chapter 5 in NFPA 654, Section 5.2.1.2, it clearly states that the life safety objectives that are laid out in Chapter 4 have to be met in the performance-based design option. Finally, I'd just note that with NFPA 654, Section 7.1.5.1, where an explosive hazard exists, the isolation devices shall be provided to prevent deflagration propagation from air material separators upstream to the work area. So NFPA 654, the guiding dust document, as a owner-operator, you need to understand it, comb through it, and then allow it to guide you to other standards that would apply to your manufacturing process. Here we have NFPA 68 and 69. Per NFPA 68, the owner-operators must be involved in the selection and the application of the prevention devices, whereas in NFPA 69, This standard works with active devices and is selected by the vendor. 69 defines the use of rotary airlocks with air material separators. Both NFPA 68 and 69 have the performance-based options outlined in NFPA 654 section 1.6. Now, NFPA 484, the metal dust standard. Because metal dust dissipates heat rapidly, NFPA has had to put a specific standard towards this application and is much more stringent towards how the dust collector is designed, located, and what safety features shall be applied to this application. For a combustible metal dust, you need to have minimum conveying velocities of 4,500 feet per minute, and they must be maintained in the system, or for any of my European colleagues, 1,737 meters per minute. Under section 4.1.4.2, the standard states, wherever combustibility can be shown to exist in the materials, full scope and requirements of the standard shall apply. Now in NFPA 484, there is the performance-based design option under Chapter 6. The owner-operator must manage their change. The owner-customer must manage the change of their system so that the system is still within the specifications of the system and the guidelines set forth in 484. Specifically, NFPA 484, section 4.1.6 states, forms of combustible metal dust that have been evaluated as non-combustible shall be required to be reevaluated whenever a change in manufacturing, processing, handling, or storage conditions creates a modified form that might exhibit the characteristics of combustibility. So we've looked briefly at the codes NFPA 654, NFPA 68, 69, and 484. Now we're going to go into the engineering controls, proper dust collector system design. There are a variety of hood designs an owner-operator could select. Hood design factors to consider include, but are not limited to, characteristics of working objects, proper capture velocities, hood flow rate determinations, air distribution, worker position effects, direction and velocity of the particulate being generated, as well as protecting the operator's breathing zone, should all be considered in the selection of the specific hood design. Based upon industrial ventilation guidelines, ranges of capture velocities can range from 50 feet per minute up to 100 feet per minute for particulate that's released with particularly no velocity in quiet air. Then your next step up at 200 to 500 feet per minute, that is the design for capture velocities for particulate that has active generation into a zone of rapid air motion. 500 to 2,000 feet per minute capture velocities for particulate released at high initial velocity into a zone that has very rapid air motion. On the far right-hand side of the screen, you'll notice a downdraft, backdraft bench. Although downdraft benches are not contained devices, due to downdraft benches' open dust collector design, they are not acceptable in combustible dust applications unless used in conjunction with remote air material separator devices with isolation. Except, and I gave you an ultimatum there, but except where the dust retention capacity shall be limited to 1 pound or 0.5 kilograms per section 8.7.3.5.1.4. All right, so Ductwork System. The Industrial Ventilation Guide provides guidance for recommended conveying velocities. Specifically, when you're dealing with vapors, fumes, very fine dust, your conveying velocities are in the neighborhood of, or are recommended at 1,500 to 2,000 feet per minute. Fine dry dust, you're looking at 3,000 to 3,500 feet per minute. Now, your average industrial dust it is recommended that you use 3,500 to 4,000 feet per minute. Coarse material, coarse particulates, 3,500 to 4,500 feet per minute. Large particles, heavy loads, pneumatic conveying, then you're looking at 3,500 to 4,500 feet per minute. Now, with regard to ductwork systems, let's take an example here of, example of 2,000 CFM. 2,000 CFM, for any of you uninitiated, 2,000 CFM in a 12-inch diameter duct, you'll be conveying that material at 2,500 feet per minute. Take that same volume of air, and now if that system's in a 24-inch diameter duct, you'd be moving the air at 650 feet per minute. In metal applications, minimum conveying velocities must be maintained at 4,500 feet per minute, or 1,372 meters per minute. If the system shown in this slide were handling a combustible metal dust per NFPA 484, and the specific section is 8.7.3.17, it states recycling exhaust air from a dry dust collector into the building shall not be permitted. And this system would therefore not comply with this standard. Now, in actuality, this system was handling wood dust, so the use of the backdraft damper with the clean air going back into the facility does comply with NFPA guidelines. Please also note the branch entry design shown on the bottom left corner of the slide, showing proper branch entries utilizing a 30-degree taper angle as quote-unquote preferred, and staggering the inlets into the main line versus a 90-degree branch inlets and 2 branch inlets entering the main duct line at precisely the same point in the main line. These types of connections should be avoided, and the next slide I'll show you what not to do. Oh, where to start? Of course, it's always easier to be critical of somebody else's work, but for the purposes of our webinar and our conversation, or my monologue, I'm going to use this picture and be a little critical. However, in a combustible metal application where the risks are high, we have to be a little more critical to ensure the safety of the operators, facility, and equipment. First, let's assume some of the machines connected to this main line are grinding and some are not. Per NFPA 484, Section 8.7.3.4, this section states, grinding operations shall not be served by the same dust collector as the buffing and polishing operations. So this ducted system would not be compliant with 484. Excuse me, I had to take a drink of water. if you notice on the far left side of the main duct, there's a capped branch inlet. Per section 8.7.3.19.5.2, the standard states, there shall be no unused capped outlets, pockets, or other dead-end spaces that might allow accumulation of dust. So here we see a non-compliant ducted system. While we do not know if this was how the system was initially designed, let's assume that the owner-operator had added additional pickups over time. Now, based on NFPA 484 section 8.7.3.19.5.4 that states additional branch ducts shall not be added to an existing system without redesign of the system, we can make an educated guess that this system is out of compliance and is in its current state. It is an imminent threat. I'd also point out, if you notice the branch line, the third from the left, there's a capped branch line which also would be out of compliance. Here's just one further example of what I just previously stated. As stated in the previous slide, under NFPA 484 and the section I referenced, there should be no unused capped outlets, pockets, or other dead-end spaces that might allow accumulation of dust, which is exactly what you see here. That would hold fuel stock for a combustible dust event, and it is not allowed in 484 with combustible metals. Okay, so the ugly. So let's look at something a little nicer. In contrast to what you just saw in the previous two slides, here's an example of a properly designed industrial dust collection system. Notice the slotted hoods, Y branches that evenly distribute the air between the two hoods, graduated ducts, long sweep elbows, and tapered angles of the branch lines connecting to the main line, all providing uniform design, function, and conveyance in the system. This is a well-designed ducted system. However, per NFPA 484, I do not see in this picture any backdraft dampers that would arrest a flame front in the ducted system. So with 484, this system would also potentially be out of compliance. Here I'll turn the presentation to my colleague, Jennifer Tedder. Hello, Jennifer.
Hey, Case, I figured my mute button out. I apologize. Can you guys hear me?
Yes, we can hear you, Jennifer.
Okay, great. Thank you. So when you're deciding which type of dust collection system to implement, a couple of things to take into consideration are particulate size and shape, as well as other characteristics such as it being sticky, abrasive, hygroscopic, just to name a few. Those things will play a large part in deciding both which dust collection technology and filter media choice to go with. Cartridge collectors can successfully handle most applications where temperatures are below 350 degrees. And, when you're dealing with extreme temperatures, 350 degrees and higher, starting to look at a baghouse type collector is probably going to be a more feasible option. As far as efficiency requirements, that can be based on several factors, including but definitely not limited to outlet grain emission needs, downline equipment requirements, as well as NFPA or EPA regulations that are, affecting or concerning your application. Emission values for both baghouse and cartridge-style dust collectors are typically 0.01 grams per DSCF down to 0.002 grams per DSCF. And generally, after a dust cake is developed in dust collectors that have either the bag or sock filter or cartridge style, will have efficiencies that are 99.9 to 99.99 on 0.5 micron by weight. And when you're dealing with a combustible dust, you should always work with a reputable supplier that has validated their equipment for a combustible dust environment. In case we'll take a little more time and elaborate on that point more in a subsequent slide. In regards to proper filter and media selection, obviously there is a wide array of media choices out there, but specifically keeping with this section of NFPA 484, you're looking at two different options that are static dissipating, one of which is the carbon impregnated media. It's commonly used in applications containing carbon black, plastics and additives, resins as well, to name a few, or where by your dust being conveyed generates a static charge. Another option, keeping with that, is the aluminized polyester, used in similar situations where dust characteristics or application temperatures may warrant the use of this type of media. In regards to some safety features, as noted in NFPA 484 8.4.3.6.2, deflagration on venting shall not be required for ductwork provided with explosion isolation systems that are identified in NFPA 69. Some of those things, an inlet isolation device is used in case of deflagration, and it's going to keep fireball or flame front from passing back to the process through the inlet ductwork. A spark trap, commonly used in applications like laser, plasma, grinding. Main purpose of the spark trap is it's going to prevent that spark generated through the process from entering the dust collector and causing a deflagration or fire. Dropout modules, their purpose, you're going to separate out the heavier bulk density materials, kind of pre-clean the dust or the fume that's entering your collector before it gets to the cartridges. It also helps to knock down sparks that could be an ignition source for an explosion. And it's obviously, I digress. It's a better option in most cases than a cyclone because it uses less energy, saving on fan horsepower in regards to the system, and reducing the total cost of operation for the life of the system. Case will explain a little bit more about safety features and give you some deeper detail in the next couple of slides. Case, you go right ahead.
All righty. Okay, so now we're going to look at the dust collector safety features for the inlet. Per NFPA 654, specifically 7.1.5.1, where an explosion hazard exists, isolation devices shall be provided to prevent deflagration propagation from air material separators upstream to the work area. So please note the picture of the backdraft damper in the right-hand side of the presentation. These style dampers have been validated to ST3 dust. Generally speaking, though, above 300 KST, you cannot use a backdraft damper, and we then need to consider some other methods, such as a chemical suppression system, suppression device, in conjunction with a fast-acting valve. It's also interesting to note that a fast-acting valve is limited to 24-inch diameters. Each inlet isolation device has its own unique characteristics and applications. At the bottom left of the slide, there's a model of an inlet spark trap. That unit there provides protection against allowing an ignition source to come in contact with the suspended dust and a fuel stock. This device folds the inlet air multiple times, reducing the velocity of the airstream, cooling the ignition source, and skimming it out of the airstream. So we've looked at the inlet on an industrial dust collection system. Now we're going to look at the housing for an industrial dust collection system. NFPA 654 will guide you to NFPA 69, where it defines the specifics of the design of the isolation device. There are a variety of outlet isolation devices available that are dependent upon the application and its intended outcome. Every isolation device has limits. Some are limited by the KST or characteristic of the dust, so knowing your dust will guide you on which isolation device to use. One final note, NFPA 69 states an active isolation device shall be inspected quarterly by a certified technician. In contrast, a passive isolation device only requires a yearly inspection by the owner-operator or non-certified person. So if you look at the center picture, you see that chemical suppression system dispersing. That's an active system, whereas on the bottom left, that's an integrated safety monitoring filter. That is a passive system, just to give you a visual of what I just described. In scenarios where you can vent to a restricted zone, validated blast plates can be used in situations where you're required to cut the flame ball length in half. In cases where you cannot locate the dust collecting system next to the exterior wall, you can direct the flame front vertically or towards a restricted area through the roof by use of a vented duct. So that's what you see there in the bottom right. That's a vertical explosion column connected to a dust collector, versus on the left-hand side, sort of in the background there, is the blast plate that I was describing. So I think if you read about my background, I just moved a year ago back from Kuala Lumpur, Malaysia, where I was for 3 years. And back in, when was it? It was November of 2010. I opened up the New Straits Times magazine, or newspaper, and saw this picture that you see now. 1 week later, my engineering manager and I visited the site, and the damage that was wrought on this combustible metal dust explosion was really horrific. The supplier of the 3 dust collectors shown in this picture had applied explosion vents but had not properly calculated the amount of vent area required for the pressure release necessary in a aluminum dust deflagration. Consequently, the vents failed and the dust collection system became bombs that ripped through this facility. Thankfully, no one was killed, but as you see there, 8 workers were hurt. I'll also say that when I drove up to this facility, I was with my engineering manager, and we looked across the road from that facility, 20 meters away, 30 feet roughly, and there was a glass-fronted building, and all the glass in that building had been shattered from the pressure wave. It was amazing what energy was released from that deflagration. That's what we want to prevent. So choose a reputable supplier. Ask questions. Find out how they, ask them how they calculate their vent size. Don't just if your supplier doesn't understand his vessel strength, the hydraulic diameter needs to relieve the pressures and the deflagration dependent upon the KSTs, run away. Don't let this happen to you. Whew, now we saw the ugly, so let's turn our attention to something a little nicer. Here is an example of a potentially compliant, but also maybe non-compliant industrial dust collection system. Let's take 2 hypotheticals. First, let's assume that this system is filtering a combustible metal dust. Per NFPA 484, and if this isn't too much information, Section 8.7.3.17, it states recycling the exhaust air from a dry dust collector into the building shall be prohibited. So if this was a system for a combustible metal dust, this system would be out of compliance. You see the ductwork coming out of the left-hand side of the clean air section of the dust collector, going down into that material handling fan, or into the industrial fan, going back into the facility with a nice backdraft damper. But per 484, that's out of compliance. Jennifer, can I turn it back over to you?
Absolutely. Specifically concerning combustible dust, the role of OSHA is, in fact, it's just to work with local authorities to enforce, the standards that have been published by the NFPA. After OSHA initiated the Combustible Dust National Emphasis Program in October of 2007, there was a catastrophic explosion at a sugar refinery. This caused them to intensify their focus on combustible dust events. And in turn, a reissuance of this program had come about in 2008. And as defined by OSHA, the dust covered by this include but are not limited to metal dust like aluminum and magnesium, wood dust, coal and other carbon dust, plastic, dust and additives, biosolids, other organic dust like flour, sugar, paper, soap, dried blood, and certain textile materials. To kind of round everything out, some of the shortfalls to compliance. The thought process of we've never had an issue. Well, it can and it will lead to noncompliance. Being proactive in knowing and implementing what is required for your process will save lives, time, and money, short and sweet. And it's the customer's responsibility to have their dust tested and to know if it is explosive. Along with proper system design, this will help to ensure both, compliance and safety. Being more concerned with upfront costs versus total cost of ownership or operation, of a dust collection system that is NFPA compliant can lead to higher combustible dust events, possible loss of life or injury, costly upgrades, and fines for noncompliance. So be sure to utilize all of the resources that are out there and available to you on the front end of your project to help prevent these issues from occurring. It is always important to use devices that are certified and tested. If they're not, those devices may not be able to perform the functions that they were originally installed for. Researching the equipment you need to be compliant and maintain safety, as well as the supplier, are good ways to avoid these problems down the road. And in having a combustible dust process or any dust generating application that doesn't have a dust collector, can and will cause housekeeping issues throughout your facility. In these cases, proper hood and dust collection design and implementation are required in order to maintain both NFPA compliance as well as proper safety standards regulated by OSHA. And with all of that being said, Case and I would be glad to turn the presentation back over to Kyle Morrison.
All right, great. Thank you both for that wonderful presentation. Before we dive into the Q&A, we do have quite a few questions. I hope we can get a chance to get through many of them. I just want to remind everyone of the short evaluation survey we were asking. I mentioned at the beginning of the presentation. It should be appearing on your screen now, and I just ask that you fill it out. Your input is important because it helps future webcasts and helps improve them. If you don't see the evaluation popping up, make sure your pop-up blocker is turned off. Now we have some questions. And joining us to answer a few of these questions is Tony Supini. He's a plant manager with Camfil APC and author of several articles about combustible dust and explosion prevention. I want to touch on a few things right off the bat. There was quite a few NFPA standards that were mentioned, 654, 68, 69, 484. What year are these standards covering? Are these the most recent standards, the requirements that you were mentioning, Case?
Yes. I'll have to go back and look here just a few minutes, and I can get you the year on those standards.
This is Tony. I can probably update you pretty quick on that. The most current standards of those four mentioned, 654 is year 2013, NFPA 484 is year 2012, NFPA 68 is year 2013, and NFP 69 is revision year 2008. And if there's ever any questions about what the most current standard is, they can be accessed and evaluated at www.nfpa.org.
Okay, so the requirements that Case that you were going over, then those are the requirements found in the most recent NFPA standards, correct?
Correct.
Okay. And these regulations, do they pertain to specific dust, like specifically metal dust or all combustible dust, or what exactly kind of dust do they pertain to?
Well, on NFPA 654 is the guiding dust document, and by utilizing NFPA 654, it will take you to other documents dependent upon your dust type. So there are specific documents for metal dust, which I referenced NFPA 484. So you'll just need to go through 654, understand which type of dust you're dealing with, and look in 654 to where it takes you, what standard it takes you to.
Okay, great, Case. Thank you. Now, Jennifer, you mentioned earlier regarding OSHA and NFPA standards. Correct me if I'm wrong, but the NFPA, they're standards, but they're voluntary. They're consensus-based standards. So what exactly is OSHA's role with enforcing these ostensibly voluntary standards?
Well, I understand that there can be a little bit of gray area. At that point, I would like to have Tony answer that, since he is much more in-depth and knowledgeable as to who has to follow which regulations and why.
Sure, and thank you, Jennifer. It's a very good question, and I think it answers a couple here that we've seen during the presentation. OSHA does in fact enforce these standards, okay? It's important to understand that they are not voluntary. They are standards. If they were voluntary, they would be guidelines. For instance, NFPA 68 turned from a guideline in 2007 to a standard, which again means that it needs to be followed. OSHA enforces these standards currently through what is called their National Emphasis Program. And I'm sorry I do not have that number in front of me, but it can be found easily with a small search on the internet, and you're looking for the National Emphasis Program, NEP, which I believe was version 2008, if I remember correctly. It was reissued in 2008, shortly after that sugar dust refinery explosion. So that's what you're looking for. That is what OSHA uses to enforce the NFPA standards currently, and I can tell you that OSHA will question your system and your preventative measures or explosion protection measures if your dust is deemed to be explosive. And to answer a question here just a little bit earlier, your dust is explosive if it has a KST value, which is called a deflagration index, that is greater than 0. Okay, and I'll go ahead and also answer another question. The owner-operator is responsible for knowing the characteristics of their dust. I can tell you that you're safer assuming that your dust is explosive rather than not, because most dusts are explosive. Most of the dust that we see are explosive. So if there's any question, there are searches on the internet that can help you out with that, but there are also standards, tests driven by standards that can determine the explosivity of your dust, how explosive it is, or in fact if it's not. And again, that standard can be found in NFPA 68. It's referenced in that standard, and it's an ASTM E1226 is the standard for that, or an ISO 6184/1. Those are two standards that are referenced in NFPA for determining the characteristics of your dust or explosivity of your dust. So there are many reputable dust testing firms out there that can help or that can perform that test and give you the results.
Thank you, Tony. Another question regarding KST, and I know, Tony, you mentioned that any KST higher than 0 means that it's a combustible dust, but with NFPA, does an employer have to follow NFPA standards if they have a KST of only 5?
Yes. Again, anything greater than 0 is a combustible dust, which then which at that point the combustible dust standards need to be followed. Again, the NFPA 654 is the guiding dust document, so that's where you would want to start. You have determined that the dust is explosive. Again, anything greater than 0, which makes all these standards applicable at that point.
Okay, great. Thank you. Now, there were quite a few questions here that get kind of specific, so just bear with me for a second there. One question is talking about recycling the air back into a building from a dust collector. Is it just 484 that prevents that? This individual has wood dust that they're worried about, and if I'm wrong, 484 was in connection with metal dust. So does 484 also cover wood dust?
No, this is case. No, it does not. 654 addresses recycling the air. 484 addresses it also, but specifically for combustible metals. So wood dust would not fall under 484.
Okay, great. Thank you, Case.
If you allow me to add just a bit to that, I believe it's NFPA 655. No, I'm sorry. 664 I apologize, but there is a standard, a specific standard for wood dust applications.
Tony.
And NFPA 654 will guide you to that with a wood dust application. So that standard is cited in there. And again, repeating what Kay said, 484 is for metal dust, that you wouldn't find anything for wood dust. And I do want to clear one thing up real quick with isolation. I've seen a couple of comments with it. Some of the pictures that Kay with the dust collector, I think was incorrectly cited as a backdraft damper, where actually it was an abort gate that is on that collector, okay, as an isolation device. What we need to know and realize is that everything in these standards is a prescriptive-based approach, okay? NFPA recognizes that they cannot keep up with current research. They cannot keep up with current or good engineering devices through these standards to protect or isolate equipment. So they make, in most standards, it's Chapter 5, where they have a performance-based solution. And basically, and I'm going to paraphrase here, it says, if you perform the correct testing and the device does what it says it's supposed to do, then you can use it. The standard's not going to limit you from that. So they might not be listing everything you've seen. So when it comes to isolation devices, the AHJ is the responsibility of the AHJ, the authority having jurisdiction, to make sure that that isolation device has the certification or the testing or whatever is required, that it meets what it's supposed to do, and in that case keep a deflagration, pressure and flame fronts from re-entering the building. So again, there may be companies that have performed that testing and can offer something that is not cited specifically in that standard, and that is fine as long as they can offer the certification and paperwork to prove that it will work.
Okay, thank you, Tony. That kind of was going to lead into the next question I was going to ask, which was for owners or operators, what specific documents do they need to have on hand for any AHJ inspecting their facility?
And that's a wonderful question. In NFPA 68, there's a list of 20 some odd items, I believe, of things that they should have on hand. Obviously, if a empowering body was to come in and investigate or ask about your protection system, one of the things, or one of the first things they could ask is, do you have documentation on your dust showing that it's explosive or non-explosive, okay, and how did you determine that? And then if it is explosive and you have isolation equipment on your system, they may ask for the certifications on that, or what did the AHJ do to approve that device? How do they know that it's going to work? So there's a list of documentation, and they all serve to and we'll at least take it this far and say that the enforcing body, and that could be OSHA many times, to prove to them that they've done their due diligence, they know what they're dealing with, and that they have taken the precautionary or the appropriate methods in abating the issues that they're going to see with an explosive dust.
Okay, great. Thank you, Tony. Here's a question that deals with a grandfather clause. If they have a process that hasn't been upgraded since, say, 2001, except for perhaps a dust collection system about 1999, the purpose of replacing the dust collecting system was better than a collection system. Should they consider a new dust collection system that included an airlock and or a backdraft design or explosion suppression system, since it's 8 cubic feet, or is there a grandfather clause where they won't have to worry about doing that?
The case covered that somewhat in his presentation, and I'll just, in case, I'll answer it if you don't mind again here, maybe answer it a little bit different way. The standard says that it's not retroactive, okay, but it really is retroactive, and I'll just say it that way. it is up to the authority having jurisdiction to determine where the retroactivity lies. And usually, if the AHJ, or let's say that they undergo an inspection and the enforcing body determines that there's imminent danger, okay, because, guys, the physics did not change of explosive characteristics of ducts and what they can do in a year. I mean, they've always been that way. So we come out and make something a standard that doesn't change the physics of what you're dealing with. So there's still, if there is imminent danger, then the AHJ is supposed to update, and it is very acceptable to update what you might already have in the facility. Again, making sure that that is done appropriately, because sometimes the older equipment doesn't have the ability to, or might not be strong enough, or whatever the case may be, to handle that combustible dust appropriately, but many times it will. So it is, you can update it. It just has to be done the correct way. So again, the retroactivity applies, and if you find that that dust collector, and going through trying to put your explosion protection equipment on it, if the dust collector is not capable of handling that, then I would say it's time to look at a new dust collector.
Okay, great. One more question regarding someone's system. This individual has a Donaldson Turret PJD system for their wood shop, and the system's exhaust is directed back into the building. Would that be in or out of compliance?
And that's a good question, and one that I cannot answer totally, because the question would be, is there an isolation device in the system? We've seen in NFPA 654, and then again the requirements of that isolation system in NFPA 69, that it needs to be there if there is a danger. Okay, and the danger is that if there's an explosion, pressure and flame fronts can be ejected through the outlet ducting and back into the building, and then those pressure fronts can blow the fuel, suspend it in air, and cause secondary explosions, which are typically more catastrophic than the initial explosion. So if an isolation device is there, the next question is it compliant? Is it NFPA compliant? If it's not, then it doesn't meet standard. If there's not one there, then a lot more questions have to be asked as why that isolation device is not there, and it stands to reason and most likely that it wouldn't be a compliant system at that point. And I want to, and also too, I apologize if I can go back on the last question just for a second and state about this replacing an old dust collector versus or updating an old dust collector versus updating with a new. I would also like to say that there should be a lot of assessment there, because sometimes you'll find that buying a new dust collector that's up on the technology, it has the ability, and it can be actually less expensive to replace that dust collector as to do everything that you need to do to upgrade the old. So there's a little bit more research that needs to be done there as well to answer that question sufficiently. Apologize about that.
Oh, that's great. Thank you, Tony. Unfortunately, we are running out of time, and I apologize to everyone who asked questions that we didn't get a chance to ask. But just remember, all of today's unanswered questions will be forwarded on to our speakers. So once again, I hope you take the time to fill out the evaluation survey on your screen to give us your feedback. And with that, that will be the end of today's Safety and Health webcast. I'd like to thank Case, Jennifer, Tony, Camphil APC, and all of you for listening in. Thank you, and have a wonderful day.
Thank you.
Thank you.